All right, this is a dimensional analysis video for your reviewing pleasure. This is mainly to show you the main steps that I'm looking for in dimensional analysis in solving your problem, how you're assigning your sig figs and how you're applying your sig fig rules, as well as kind of where you're going to get points on the test. Okay, um, so we'll go ahead and walk through the problem first, and then once the problem's been walked through, I'll show you where you're getting the points. Okay, so first, let's go ahead and take what we're given, and we are given 0.8 gallons. So we're going to go ahead and say we have 0.8 gallons, and I'm going to put that over 1, right? And then I did include all the conversion factors. They're right here, okay? So what kind of conversion factors am I going to need for this? Well, if I'm going from gallons, I need to have something that's involving gallons. And the only one that involves gallons has to do with quarts. Okay, now obviously quarts is not where I want to be. I want to eventually get to liters. Well, the only liters things I have is the liters to 1,000 milliliters. So if I had a conversion that went from quarts to milliliters, then that would kind of bridge my gap. And hey, wouldn't you know, there's one right there. Okay, for this particular problem, we are not going to be using that equivalency statement. So we'll go ahead and do our first conversion factor, which is I'm going to go to quarts. So I'm going to go 1 gallon is equal to 4 quarts. Okay, and then go with another conversion because I'm at quarts, I'm not at liters where I want to be. I do happen to know that 1 quart is equal to 946 milliliters. And then my last conversion, because I don't want to stay at milliliters, is to get to liters. I know that there's 1,000 milliliters in every 1 liter. So if I cancel out my units, right, quarts are gone, gallons are gone, milliliters are gone, and I'm left with just my liters, which is a good thing. That's what I want. Okay? So from there, I'm going to show my intermediate steps. So I'm going to go 0.8 times 4 times 946 times 1 liter. Okay. Remember, I don't put the other units in there because I've canceled them out. And I'm going to go 1 times 1 times 1 times 1,000. All right. Now, when I do this multiplication, 0.8 times 4 times 946 times 1, I need to employ the sig fig rules because I used 0.8, which is my beginning number, and I need to pay attention to sig figs there. All right, so if I do that multiplication, enter my calculator here, I end up with 3027.2 liters over 1,000. Now, like I said, we have to apply the sig fig rules, so it's not really going to be 3,027.2 liters. It's going to only have 1 sig fig since I only have 1 sig fig in my beginning number. So it's going to be 3,000 liters. Oops, check that. You need to get rid of that 0 right there. Okay, so let's go ahead and rewrite that. It would just be 3,000 liters. Okay, so I have 3,000 liters over 1,000, which obviously is going to be 3 liters. Okay, so there's my final answer. So where I am assigning points. Okay, I went ahead and changed that last part of the equation so it'll be nice and easy to see where our points are. Okay, you're going to get 1 point for giving me the initial setup. Okay, that's 1 point, right? And then you're going to give me, or sorry, you are going to get another point for crossing out the units and circling the unit that you have left. So all the places in red where I canceled out units and circled that unit, we're good. That's another point. Okay. The showing me this step right here, okay, this step right here, where you have all the numbers that you need to multiply, but you haven't multiplied them yet, that is also going to be a point. So there's 3 of the 5 points. Actually applying the sig fig rule and drawing this other step is going to be yet another point. And then lastly, getting the correct answer is going to be a point. Now remember, you need to make sure you have units. Okay? Now I'm saying points, what I'm really meaning is percentage. Okay? Because if this is a 5-point problem, then each one of these is worth 5 points, or each one of these is worth 1 point. If this is a 10-point problem, then each one of these little divisions are going to be worth 2 points. Okay? So for example, if I just did the setup, right? If I did the setup and I did the first intermediate step, this guy right here, and it was a 10-point problem, I would have got 4 out of 10 points. Okay? But if I did the setup, I did the intermediate, and I canceled out my units, then that would be 6 out of 10 points. All right? So let's go ahead and do one more problem. Okay? So convert a density of 1.39 times 10 to the 6th. Okay, so this is like a little typo. It should be to the 6th, okay, as a exponent. Milligrams per liter into a density with dimensions of grams per milliliter. All right, so first thing I need to do is I need to write out which conversion factors I need. Okay, so what kind of stuff I need to do? I need to convert milligrams to grams, and I need to convert liters into milliliters. Now, if you're wondering where I'm getting this, here's my milligrams right here. I need to convert that into grams, and my liters here, I need to convert into milliliters. Right? Because a density unit is a mass unit divided by a volume unit. So each one of those two units in this derived unit needs to be converted. So milligrams need to convert it into grams, liters need to convert it into milliliters. All right. The conversion factor is pretty easy. We know that we know what milli means. Milli means thousandth. So there's 1,000 milligrams equal to 1 gram, but there's also 1,000 milliliters equal to 1 liter. So those are our two conversion factors for this, or equivalency statements for this particular problem. So let's go ahead and set the problem up. All right, I'm going to go with 1.39 E6. This right here, E6, is the same thing as writing this number. This number right here and this number right here are the same thing. Okay, it's just another way to write it. It's usually a little faster instead of having to write the exponent. And if you're ever typing in an answer, just doing a capital E with the number is a lot easier than doing times 10 and then 6. Because then if you don't have that little shortcut, then you end up looking like, oh, it's 1.39 times 106, and that doesn't really work. Okay, so I'm going to take my unit, which is going to be milligrams, right? Milligrams per 1 liter. Remember, do not put milligrams over liters as a numerator. It's milligrams here on the numerator, liters is as the denominator. All right? Remember, I have two conversions, so I'm just going to do one at a time. It does not matter which one you do. All right, so I'm going to go here, and I have milligrams. So I'm going to do the mass one first. Milligrams to grams. I know the conversion factor. I have 1,000 milligrams. That gets me 1 gram. Okay? Great. Milligrams cancel out. I'm left with grams. All right? And then I'm going to, because obviously if I stopped here, I would end up grams per liter. That's not what I want. I want grams per milliliter. Okay? So I'm going to do one more step. I know that 1 liter is equal to 1,000 milliliters. Okay? Now I know that liters needs to go on top because over here in my first section, I have liters on bottom. So because of that, I need liters on top so it'll cancel out. Okay? So I will then cancel out my units here. Liters cancel out. I'm left with milliliters. So now if I just multiply or just had the units in here, as you can see, I have grams on top and I have milliliters on bottom, which, hey, that is, look over at our problem up top, right? Grams per milliliter, that's exactly what I want. Okay? So I'm going to go ahead and do my intermediate step down here, since I have the conversion factors over there. Now, you can do one of two things. You can leave the 1.39 e to the 6, or E6. You can leave that in there, and you can type that into your calculator, and you can solve it using scientific notation, or you can always convert it into standard notation. Okay, in this case, it would be 139, and if I move my decimal place over 6 places, 1, 2, 3, 4, 5, 6, and I fill in my zeros, that means I end up with 1.3 million, which is 1,300,000. Okay, so I'll go ahead and get rid of the little waves of decimal. Right? So I end up with 1.3 million, or 1,390,000. Okay, and this is, there's no unit here, right? Because I canceled out milligrams, times 1 gram times 1, okay? And I put that over 1 times 1,000 times 1,000 milliliters, okay? I'll do the math, and I end up with 139,000 divided by, grams, divided by 1 million, because 1,000 times 1,000 is a million. 1, 2, 3, 4, 5, 6 milliliters. Okay? So I can always cancel out my zeros, right? 1, 2, 3, 4, that's as far as I can go. So I end up really with 139 divided by 100, which is the same thing as saying 1.39 million divided by 1 million, right? So I write out my final answer. And understand the sig figs are the same. They didn't change because all I did here and here was multiplied by 100. It was multiplied by 1. So the sig figs didn't change. Okay? So my final answer is 1.39 grams per milliliter. And that's my final answer. Okay? Again, let's go ahead and assign points. You get 1 point for writing out the conversion, or getting out the, having it set up. You get 1 point for doing your units, this, and circling the units that you have left. So your cancellation of units and circling of the units, you get a point there. You get 1 point for doing this setup right there. Okay? The intermediate step that you haven't done all the math yet. Then you do another intermediate step where you actually show the products that you did from the previous intermediate step, and you apply the sig fig rules as needed. Okay? And then you get a point for getting the correct answer with the correct units. Okay? Remember, no units, no points. Okay? Now, question is, what if I do something wrong here? Okay? What if I do that wrong there, but I still do the math correctly, the function correctly, and I get a different answer? Well, that means you would get this part wrong, and you would get this part wrong because you did not get the correct answer, because you didn't do your setup correctly. Okay? So if I got those two wrong, and then say this was a 5-point problem, then you would have ended up getting 3 out of 5, which is a D. Okay? So if you guys have any questions, by all means, ask me in class, or you can shoot me an email, and I'll help you through it. This is not, obviously, the only video on YouTube or on the internet to find out how to do dimensional analysis. There's a lot of them. You're welcome to look through them. However, be forewarned that those other videos may not apply the sig fig rules the same way I do. And since I'm the one that is kind of grading your papers and controlling your rubric for grading, you'd probably be wise to follow my rules. Okay? That's it. And if you guys, again, if you have any questions, make sure you ask.